All right. So it's 3 p.m. So, Praveen, let's get started.
Sure.
Hello, everyone. Thanks for taking time and joining us today on hopefully an insightful session for us. And this is Nitin, a product marketer here at Utthunga. I welcome you all to this session. So, before we get started, let me first remind you that these LinkedIn sessions are aimed to have better engagement with our audience. So feel free to comment and leave any questions you have for us, and hopefully we can answer that towards the end of the session. So let's come to today's topic itself, and uh, as the name suggests, right, democratizing platform data. This seems pretty radical, but it is already a reality. So to discuss this topic with me, I sort of have to pick someone's brains, and who better to pick than our chief OPC solutions architect, Mr. Praveen Kumar Singh. So a little bit about Praveen. He has more than a couple of decades experience in the OPC technology space, and also holds three very important patents in OPC technology, and a very relevant person in the space, and an influential sort of mind in this whole thing. But on a lighter note, apart from being our OPC guru, he is also I would say, our chief fun officer and one of the most jovial person in our team. So thanks, Praveen, for being a part of this, and we're looking forward to this.
Thank you.
So,
Thank you.
uh, Praveen, I came across a very interesting stat earlier,
hmm
and it sort of highlighted that 80% of the manufacturers in the world have less than about 20 million revenue,
hmm
and these small medium enterprises, or SMEs as we call it, right,
hmm
they are always playing catch up with technology
Yeah.
advancements because they don't have too much of a say early on before anything happens.
Yeah.
And the common mentality, like we sort of spoke about earlier with Andres Fath in the last session, is that if it works, why change? And that's sort of how things have been, and it's more prevalent than we actually think.
hmm
And this sort of leads to this slow decision making process as we
Yeah.
see it in our industrial automation space compared to any of the other sectors, for that example.
hmm hmm
So let's say, let's take for example the factory floor, plant floor, or whatever, shop floor as we call it,
hmm
where the heart of the industrial automation actually happens, right?
hmm
So assuming that these SMEs or any of these manufacturing facilities are
hmm
looking into the future and want to be sort of future proof, what are some of the key reasons why these organizations are looking to retrieve data from the plant floor
hmm
as effectively as possible
hmm
from, let's say, the plant to the business floor, as we call it?
hmm So, see, Nitin, so are we going to slides? Yeah. So, can you? Yeah. So basically, if you look at the current situation, right? Everything is happening at the shop floor, right? The real work happens at the shop floor, and you need
Mm-hmm.
to make quick decisions sitting in the central room, or in our corporate office on that. Now, how do you make decisions sitting at a remote location for a shop floor, right? The only way to do it is a data, and
Mm-hmm.
not only a data, quick response data. You need to get a data in a quick amount of time, in a quick response time, so that you can make decisions. Okay.
Mm-hmm.
Now, not so. I'm, I'm sorry. There are two types of decision we make, right? One is to run the plant smoothly and
Mm-hmm.
take care of any anomalies and all that. Because understand, most of the machinery that you have is very expensive. That this industries are using. Okay, automation industry in general, and if you go specifically towards oil and gas, most of the machinery that you're getting used are very expensive.
Mm-hmm.
And any breakage in that industry, I mean, any small breakdown in that, okay, can lead to a huge amount of financial losses, because the
Mm-hmm.
commodity is very expensive, right? I mean, what we are trying to extract, the oil.
Mm-hmm.
The whole purpose that we are trying to do with the help of getting a data is to make sure we have a continuous production of the oil or whatever commodity you're
Yeah.
trying to get it there, right? Once you start getting a data, Okay, now getting a data is just not important. Getting a data in a quick response time is important, because if the data comes to you, okay, maybe after 10 minutes, 15 minutes, okay, most probably that occurrence has happened. Okay, if something, you was triggering something that, okay, this is going to happen, and you came to know only after 15 minutes, mostly it is done.
Yeah.
And you can't do much about it, right? But if the same thing comes to you in a 1 second, 2 second time, okay, then you can take an action. You can prevent that thing to happen before it is happening. Now, that's one part of the story. Okay, second is, once you start getting this data, okay, then you can start also realizing if what will happen in tomorrow, day after tomorrow with these machines, right? So for both, for having the current maintenance and all that, to make sure that plant is running safely, also to take informed decisions for next week, 1 month, 2 months, data is very important. Okay.
Yeah.
Now, can you go to the next slide? Yeah. Now, so if you look at this structure, right, what happened is, this structure was built over a period of time. They started somewhere in 60s, 70s, and started getting built, and then they started adding a layer as more and more intelligence came in the plant floor, or in the in the industry. Okay, but because of that, what had happened is, there are multiple layers, okay, and data gets stuck at different layers, because each of these layers that you see on the screen, field devices, control devices, station, work sensor, they all work in a different languages. And if you want to talk in industry terms, different protocols. Now you can think of a protocol as a language that we speak. Okay. Now if you have 10 people, okay, or 20 people sitting in a room, and each of these people are speaking a different language, just imagine the communication that will happen.
Yeah.
Right? It will be a chaos, because nobody understands what other guy is saying. And you spend tons of amount of data or time just to convert one language to another. And this happens here also, because at the field device level, there's a different set of protocols which has been built. Okay. At the control device layer, the protocols change. And this is happening at every layer.
Yeah.
Now, as with any conversion, language conversion, okay, or protocol conversion, when the data starts getting converted, or information getting converted from one language to another language, or one protocol to another protocol, it starts losing some of its original information. Or you can say it starts getting corrupted. Sometimes the data gets lost, sometimes some junk data gets added, and that becomes part of the real data which the next layer is feeding into. Okay, now how can an enterprise layer person can make a good decisions, or cloud can make a good decision, if the data is corrupted, or the data is lost in transition? Right? And that's what we are trying to change. Okay, we are trying to come out of this pyramid structure and trying to have a flat structure, okay, where you may have this layer, may not have, but the data will be a lot more seamless. Okay.
Got it.
Maybe, let's go to the next slide. We talk about that in the next slides, right?
Yeah, so you mentioned about this whole layered structure, and what I can sort of infer from that is, we're tackling a couple of things here, is where you're getting access to real time with like a flatter hierarchy system, and also you're getting no loss, trying to minimize as much loss in the system, so that you have as much data higher up, so that you can analyze all of this and make decisions a little more quickly and make more better stuff, right?
Yes.
And so which sort of brings me to this, where you were trying to say how this data can, without being sort of applicable in a siloed way, how each of these layers can sort of be optimized when you bring OPC UA into the picture, for example, and how the convergence happens itself.
Yeah. So if you look at it, this level 1, level 2, level 3, level 4, right? And I mean, there's a key thing written there. The level 1 and 2 belongs to manufacturing zone, whereas the level 3 and 4 goes to enterprise zone. And as the function demands, the above 2 layers are doing a lot of work with the cloud, with a lot of analytics, decision making, and all that work happens there. Production, the predictions about the future. Okay, whereas the level 1 and 2 is real time. There's a lot of real time data that is moving around. Okay, and there are a lot of critical assets there that you're trying to protect, and you're trying to make sure that the maintenance happens it gets a required service at the correct time to make sure they are running as required. Okay, so these two layers were doing a very different job, and now comes another additional layer, which is cybersecurity. Okay, see, when the industry started, okay, internet was non-existent. There's no internet actually, right? So most of the protocols which were built in that era did not really worry about the cybersecurity or that kind of threats. Now it's a reality. It is happening, right? There are so many attacks that has happened on so many industries, okay, and it has brought down the entire thing. Now you have to have, because of that, you have to have a separation between level 2 and 4, or a kind of a DMZ or firewalls which are separating the layers. So now you want to protect the data or protect the setup as well as connect the setup, right? You want to make sure they are separated enough so that if some hack happens, because anything which is connected to internet, okay, has a high chances of getting hacked. It's a practical possibility. Okay, and the biggest panic for the industry or automation industry is that if the hack goes to the OT layer or the layer where the devices are getting operated, it can bring down the entire plant, because now you're directly affecting the machines which are controlling, or the PLCs and all that, which are controlling the real machines, right? So you want to have the separation, at the same time you want to connect them seamlessly. Okay, and that's where OPC UA plays a very major role. OPC UA has been designed in such a way it can work on all of these layers, level 1, 2, 3, 4. Okay, there are different profiles given in OPC, which can make sure that you have a small profile or small server running at the level 1, and you can have a very big desktop server running at level 4. And because now they all speak OPC, okay, that data corruption or the different speaking language problem is solved. The data goes in the same format all the way from 1 to 4. That's one. Second is, OPC UA requires minimal ports. With the TCP/IP communication, if you go by TCP/IP, which is a predominant communication, it just requires a single TCP/IP port open across firewalls. So now IT guys are having a good time, compared to the classic world, OPC classic world, where it uses COM/DCOM and tons of ports. It was a nightmare. Here we have single ports, so it can be configured very clearly in the firewall with the rules and all, saying this port will be used for this protocol, and this kind of this protocol and this kind of data, right? At the same time, because security was built inside the UA, okay, you are using a state-of-the-art industry standard security to encrypt the data. So even if someone reaches there, you just cannot get the data because it is going on a secure channel and has a industry standard security. So it is just not easy to break in. Okay, that way you get an effective convergence of a data, OT/IT convergence. With that separation, if something gets wrongly hacked or something is compromised, it can't come down. Data moves up, but the security is not compromised, which is the win-win situation and the real OT/IT convergence with the OPC UA.
Understood. So, considering we touched on OPC UA itself, right? So, without what I want to sort of understand for the benefit of us is, without going into too much detail of the spec itself, can you give us an insight of what the PubSub spec itself fosters, and is it at a mature stage, and are you already seeing wide-scale adoption of this particular the part of the OPC UA specification itself, and how this is maybe like helping with whatever OT/IT communication, and also in some way, from what I understood, is even the whole plant floor machine-to-machine communication as well.
Yes. So basically, this is first thing, it's a very interesting question, okay, and it's not like a question, it's like a debate subject of discussion. We can speak on this for a whole day actually. So see, OPC UA till 17, till 15, 16, this was TCP/IP request response kind of protocol. With the request response, so now it solves the need at the lowest level, where you have a limited machines that are talking to each other. Okay, but beyond a point, the request response always is have a limitation that there are two parties are connected, right? So the communication can happen based on the minimal strength of the party, right? If this guy can talk at 1 second, this guy can talk at 5 seconds, then it has to be 5 seconds. You cannot use 1 second, right? Because that's how the request response works. Whatever you try, this guy will not respond before 5 seconds. So request response, TCP/IP works seamlessly. It has its own advantages and it has its own functionality at the lower level, at the OT level. But there are cases where you want to publish a data without worrying about the server, or client wants to publish a data or without worrying about the server, or server wants to publish a data without worrying about the client. That's where OPC UA PubSub was introduced. So there were two reasons for PubSub to come in. Okay, one, it gives you that publish subscribe mechanism where you can start publishing a data. As you can see in the picture, we have a publisher, we have a subscriber, and you have PubSub applications, which can be a broker, where publisher is sending the data to a broker without worrying about the subscriber, who's the subscriber, and can choose to do it at his own speed, at his own subscription time. Subscriber can take a data from the same broker at his own speed without worrying who the publisher is. The advantage here is, as number of subscribers are increasing, publisher doesn't go slow. And if the publishers are increasing, subscriber doesn't go slow because it is handled in a broker way. And there is a broker layer in between. That's one. Second is, because this was a broker mechanism, it is working on some of the industry standard, which is MQTT or AMQP, okay, which made cloud players very interested, because this is how most of the clouds interact today. Okay, and because of that, what has happened is most of the cloud players today, which are dealing in IoT domain or IoT domain, like Azure IoT Hub or AWS Greengrass, they all started adopting OPC UA. In fact, Azure says openly, if you want to use the IoT Hub very efficiently, OPC UA is a mechanism. You start publishing a data in OPC UA format, we understand natively. Okay, so that's an advantage that OPC PubSub brought in. First thing, it came out of that limitation of request response. Okay, you can just keep publishing a data. It became connectionless protocol, kind of from the connection oriented, where you are publishing a data at your speed without worrying of the subscriber. Okay, and the broker will take care of the middle layer will make sure the data gets delivered to the people who are subscribed it. Okay, second is, because the mechanism was AMQP or MQTT or this kind of broker, okay, you can use the same data at the cloud layer. Now, once the cloud comes in, it has totally a different ball game. Now, OPC UA started going all the way from L1 to the cloud. Okay.
Got it. So with the specification itself, because I sort of have an input into this whole thing, right? So I understand that we as Utthunga have been part of the PubSub working group or the specification farming itself before it was as a release candidate.
Yes.
What at a high level, can you sort of give us an insight into what our role has been in that, and what is our key sort of proficiency, I would say, in this particular space?
Sure. So what happened is, again, we are earlier adopter of PubSub, because when PubSub was getting developed, when the foundation start making a specification, they have to have a working implementation, right? They have to have working examples. And we were one of the players who started participating in that. We came up with the working examples. Okay, we gave them a working samples and examples, because of which, okay, we started having a very good idea on how PubSub works. Okay, and because we started having a very good idea on how PubSub works, we started building some products on that side. Okay, which can give you a better lead time or ready-made adaptability on the PubSub protocol. Okay,
got it.
So that is where this product comes in picture that we have on the screen. Okay, Utthunga Builtin Product called as OPC PubSub Bridge. Okay, now as the name suggests, okay, it can do both the roles. So we in the last slide we saw there's a publisher, there's a subscriber, right?
Yeah.
This is a product which can actually act as a publisher, as a subscriber, both. Okay, so what it can do is, it can get a data from the lower level data sources, whatever it supports. And we have a big roadmap for this, right? This product is just 1 year old in the market, and we already have a very few data. So very common, mostly common use data sources like UA, DA, Modbus kind of a thing. But as time goes on, we'll keep adding more and more data sources. So what it can do is, it can take data from all these sources and publish it to a broker. Okay. and the vice versa. It can get the data from the broker and push it back to this sources. Now, if you take, for example, UA, suppose it can talk to an OPC UA server, which is a TCP/IP flavor of the OPC UA. It is taking a data of the OPC UA TCP/IP format and converting to a PubSub structures. Okay, whereas in case of DA, it does a lot more. There's no format itself. Now we'll talk about that more later. But if you look at the common use cases, right, because it can do all that, it can act as a DMZ gateway. It can get the data from the lower level because it can go there to the cloud. Okay, it can also, as I told you, it's one of the one of the sources is a DA. It actually means it is now getting a data from the classic servers, which had no information model, this to cloud. Okay, plus it also has a store and forward option. So in case a connection breaks, it can get you a data, okay, loss free. It can store a data. Once the connection is recovered, it can take it up. Okay, now based on the user, now we also have a customer, we have a people where they are saying, just get me a protocol bridge. Okay, they have their own framework. They have built. See, typically, most of the industries start struggling when they start going down the layer. Most of the industries. Anybody who has a lot of products on L4, L5 layer, they don't want to go all the way to L1, L2 layer, right? Because it's not their domain.
Correct.
And we have use cases like that where a customer came and said, hey, I am managing my L5 and all that, and I'm very good in that, but I'm not. I really don't want to get to L1, L2 layer. It's just too much of work. Can you get me just a protocol bridge which can get me this? Okay, I want to see all the data coming from all the sources in a neat OPC UA format on my broker, on my cloud. And we can do that. PubSub can do that. It can act as a protocol bridge. Okay?
Got it. So you, I think, covered at a broad perspective all the use cases that this particular product can play a role at.
Yeah.
But what I'd like to understand now is PubSub itself has opened up a world of new opportunities and possibilities with this whole thing, right? And how that data can be utilized to sort of run very complex algorithms at high computing at the cloud level and determine whatever your OE or performance, predictive maintenance, and all of that comes into the picture. Now, if I can understand one unifying sort of use case from the ones that you mentioned, in a typical sort of OT to cloud sort of integration, if you can go into a little more detail on how that particular use case can work, then I think that will be very sort of helpful for the audience itself.
Yeah. So, so what we are seeing on the screen, right? Basically, so there are so your question has two parts, right? Yeah. One is how you are getting a data to a cloud. Second is what you can do with the data in the cloud. Yeah. Okay. So let me first answer the second part of the question: what we can do in the cloud with the data. So, see, OPC or the automation industry always had a lot of data. Okay, because there are thousands of sensors. The sensors are giving data at every second. Just imagine the amount of data we are generating with that, right? But with all that, you are hampered. You cannot do anything with the data. If you look at it, we are not using 10% of that data because we are in a reactive mode. Yep. What a reactive mode is: when the problem happens, you take a action and you solve the problem. Okay. Here the whole challenge is how fast you can react to a problem. I'm sorry. The whole challenge is how fast you can react to a problem, because you are dealing with for example, oil and gas. You are dealing with a flammable substance. Okay. If you don't react sharp enough, you may lose the asset. Okay. Yeah. That's not a good thing. You cannot keep relying on the reactive maintenance for long, and it's just killing them. Because they have to have people on the time, 24/7, watching the assets just to see when the failure happens. Now, what if you get that data? Okay, with that data, you start finding a pattern. From that pattern, you can start analyzing and find out when the failure is going to happen down the line. Right. For example, if you take an example of a pump, a shaft, a rotor moving on a shaft, when the rotor moves on a shaft, it also wobbles, right? Because it's friction, Now, when this wobbling as the time goes will keep increasing, because of the friction. And there's all, you always need the realignment after a point, after 7 days, 2 months, 3 months, right? What if this wobbling can tell you 1 month upfront that this will get deflected or it will break the shaft, it will come out of it, and you go and repair it. Currently, there's no mechanism, or there are not many good mechanisms for that. With the cloud coming in picture, with all that processing power, you have it, you can solve this problem. You can run your articles in the cloud, get the data. Okay, that is what this, the whole data science and predictive maintenance are all about. You get the data. Now the advantage is, because of OPC UA, you're getting a clean data. Okay, you're getting a data, lot of context because of the information model that you have. A lot of context comes in, measuring unit and all that. Data becomes a lot more meaningful. And when you run analytic engine on that, you can find all these use cases. Now, this is first part of the maintenance. Second is, with the same data, now you can start increasing your production also. Because now you can start finding it out why machines are not performing at the optimal level. Okay, so it can solve a lot of problems. First, it can reduce your breakages, breakdowns, and you can have a zero breakdowns in the year, or zero lost time. Plus, you can start making good decisions by reducing a load on a machine or increasing a load on a machine when you know the efficiency is not getting completely utilized. Okay, now I'll just come to this. So how are we doing it? If you look at the diagram on the use case, the data on the cloud. So we talked about data getting to a cloud, but how are we getting it? If you look at the diagram, this is a typical, so the pyramid structure that we keep talking about, right? I mean, that's not really a pyramid, right? I mean, it is actually like this. They have level 0, level 1, level 2, level 3, level 4, which are logical layering based on the equipment that you're using. And level 0 is closest to the real assets. They are the ones which are monitoring the assets. Okay, and then they start giving a data to the next layers. And each of this layer was always coupled with these protocols, because they had different protocols. They were stuck. The data was stuck at different layers, and all when it was coming up, it was getting corrupted or getting converted. Now, let's understand how this data goes to the cloud was one of the use cases. So here we have the PLC, some PLCs which talk Modbus protocol, which is very common. This is one of the most common protocol industry uses. What we are doing it, we have the PLCs which are talking Modbus protocol. We are using one of our products, which is OPC Modbus server. Okay. Now, the other aspect that we are looking here is redundancy. When we talked about the data is so critical, when the data is so critical, they want to make sure to get the data at all the cost. Now, what if the link goes down? Okay, what if one of the machine goes down? The machine, some Windows update came in, something machine got rebooted. That's why most of the plant also wants a redundancy. They say, I want a redundant channel so that I never lose the data, because such a critical data. So they have two Modbus servers which are pulling the data from redundant pairs, PLCs, but the data is same. Then we have a redundancy broker also. We have another product called redundancy broker, which talks to both of these products as a UA client and gives a unified address space or information to the next layer. Okay, but it internally manages both the servers, so it will have different modes based on criticality. Connect to both of them, but make sure one of them goes up, and if the failure happens, we switch over. Okay, and then broker will get this data, give it to the PubSub at the top layer, and PubSub can put the data on the broker, which can be in premises or it can be in the cloud, and that's how data goes all the way from the level 1 to the level 4 with the cloud. But now if you look at it, from level 2 onwards, all the way it is only OPC UA. There's no data loss. Now let me bring another interesting aspect here. This is one of the use cases where the client may have a OPC UA server for Modbus. They say, I don't want your product to go below L2 layer, you start from here. But actually, PubSub also supports Modbus natively. So the client is open, and he says, I don't want you to, you can just, you can just implement all that. Just get me data from the L1. My PLCs are speaking Modbus and the cloud. We can do that. The PubSub Bridge can come all the way to the L1 where you have the Modbus protocol, get the data and push it to a cloud. And because it has a store and forward ability, okay, it can keep getting a data. Okay, if the top level link breaks down, it can actually get the data and push it there. Okay, so it actually can go all the way down depending on the users. We can take care of multiple use cases.
Got it. Okay, so let me come to this now. So I think we're pretty much bang on time, but
Mhm.
we'll take a couple of questions that has come in. Uh, so, what role does OPC, what role does PubSub itself play in brownfield facilities?
Okay. So, see, okay. So, what is okay? So, if somebody says brownfield facility, right? What first thing is what is brownfield facility? A brownfield facility is which is already built upon. It already has a lot of devices which is being used for some time, right? And they are trying to put new devices, or they are trying to put new technologies there. Okay, so if you take any automation industry, right? I mean, automation industries are very, very cautious about the fact that with all the upgrades that are happening, nothing should break which is existing going on. They cannot lose data. They cannot stop a production, and say, just close our plant and we'll upgrade. No, it has to happen in parallel. Okay, so they have to make sure whatever is working is existing, already working, and then they slowly want to go to the cloud, or new technology. At the same time, this is the most common use case that we have, that please get my OT data to a cloud. As of now, we have at least 4 to 5 big customers who are asking about the same use case. We have a data at the lower level. We have a brownfield, with XY devices. We want this data to come to a cloud, and we want this data to come to a cloud seamlessly with security. Okay, we don't want to compromise the security. We want to make sure all the firewall rules are properly done. Okay, and at the same time, we want the data to be utilized perfectly in the cloud. Now, all these use cases can be done with OPC UA plus the PubSub format. As I said some time back, right? Any cloud player, see, most of the guys who are using cloud will be either using AWS or Azure and all that, right? All these IoT platforms understand OPC UA PubSub natively. What it means is all their equipments, all the components they're using for, processing, data cleaning and all that, they can understand OPC UA natively and start processing it. Right. So if you put a component at that level and start converting in OPC UA PubSub, on the cloud side, the job becomes much simpler. You don't have to write an adapter layer or another layer, to just make them understand. That's first part. Second is, I mean, if you take our product, right, PubSub Bridge, because on the south side, it can talk with the multiple sources, can get data from all those brownfield devices that we talked about. Maybe somebody has a DA server, OPC Classic server, somebody's talking a Modbus protocol, somebody has UA, or we can support multiple protocols, as time goes. If it's required, we can extend the protocol layer also, or we can talk to another server, which are protocol servers, meaning they talk different protocol south side and get data in the OPC. Once we get the data, we convert to UA format, and then it is easy to consume for a cloud. So that's the advantage OPC UA PubSub brings in.
Understood. So one maybe last question, Praveen. One very interesting thing at a high level. Considering the hierarchical level communication is almost not applicable with the introduction of PubSub, does the ISA 95 pyramid, as we talk about, still have a role, or will it continue to have a role in the automation setup?
Oh yeah, I mean, see, that layers were for a reason. That layers were built for a reason. As I said, everybody wants to make sure security is intact. Okay. More the layers, more the gates are there. The data, just to get to last level, you have to open so many gates, right? So depending on the customer, it is actually a customer's decisions. Depending on who the customer is and what he wants to do it, he can choose to have this layer, or he can choose to remove the layer. Okay, because what the layers are, I mean, see, if someone wants to do a lot of processing at the L1, L2 layer, okay, like he wants to do edge computing, and he wants to do some cleaning up, he has a huge amount of data. Their plant is very big, huge amount of plant, and they're getting data from millions of sensors per second. Just imagine if you start pumping that much data to a cloud, even cloud will have a problem, right? So you want to do some filtering at the lower level before it goes to the higher level. If you have that kind of a scale of a plant, and even security becomes more paramount, you may want to have the layers. Okay, but if you're a smaller player, you have a very minimal devices, maybe 10 to 12 assets, small small production unit. You may not want all this thing.
Correct.
And you also know that, based on the plant size, the operating cost also is lower, higher, right? If you are very big plant, you can afford to have this infrastructure. If you are a smaller plant, you can't. Earlier, the problem was the layers were there. You cannot just skip the layer. Because that's how the communication happened. Now, with the OPC, you are coming in between. You can get the data as we saw with the help of PubSub, right? I can get the data all the way from one, go to L4, okay, and get it to a cloud. So depending on the customer, he can choose to go with these layers, or he can choose to take out some of the layers and make it a lot more slimmer. Okay, so I would say that the layers still exist, they are applicable depending on what customer wants and their scale.
Correct. So I think from what I sort of understand about this whole pyramid itself, the reasoning behind why it was formed as a pyramid has a different set of applications that can relate to different characteristics of that particular set of devices in that. But this again is maybe a little off topic, but for sure it might still definitely be relevant in the future. So I think, Praveen, I've covered everything I wanted to ask. I think I sort of want to end it with a couple of things where you said the main objective is to be proactive than reactive, right? And I think that sort of summarizes this whole objective of having data whenever you need and doing something with it, and how OPC UA PubSub itself plays a role in this whole thing. So I think that sort of concludes our session, Praveen. I think thanks so much for giving us those inputs. And hopefully, I think we'll have a session very soon and with another topic. So until next time, we'll see you soon. Thank you.
Sure. Thank you very much. Thanks for inviting me.